So, peace be upon you, everyone. Today, I would like to introduce to you something about data compression algorithm. So, without wasting a lot of time, let's get into. First of all, who I am. I am Ahmed Sami, senior software engineer at EPAM Systems. Also, I'm a diving instructor. I'm a PADI master scuba diver trainer. I'm a sport enthusiast, knowledge sharing. I like to share knowledge. That's why I consider myself a mini YouTuber with two channels like Status Code channel and Exploration Echoes channels. Before getting into the data compression itself, I would like to introduce you something very important. That's the reason why and behind this presentation. Why should we know about data compression? One of the scenarios, it happened to me during the development. I was working on a separate project. It was only for myself, and I stuck with where to store my files. When you receive a file from the front end and you would like to store this file in the back end, you store it on a file system just as a file, or you store it into the database. I got into, okay, I can store it into the database, so compress it, why not? And I start to compress the file. It works fine at the beginning, but later on, I realized no significant improvement in the compression. Then I realized that certain files, you can't compress them anymore because they are already compressed. But I didn't know that other things. So that where we will get into our content. The content of the presentation today will be introduction. After the introduction, why compression itself is matter, and then type of compressions we have. Also, why doesn't compressions always work? Performance and trade-offs with the compressions, and final thoughts, when to use, where to use, and how to use, and latestly benchmark. So let's get into our introduction. What is data compression, in fact? Data compression, it is usually a technique that you can compress files to reduce storage and to transmit a large file sizes by reducing it. But that's very interesting because if you notice that we use compression on a daily basis live, if you open your laptop right now or your computer right now, you realize that you are using images. Images are compressed, audios are compressed, videos are compressed. All these files are already compressed and written by specific algorithm. Also, when you use WinRAR, WinZip, 7zip, all these are compression algorithms who are used on a daily basis. So compression is really powerful technique for optimization file size. But however, and that's so important, that not all compression will work as you expect. Why? That we are going to discuss later. There are some trade-offs when you are using data compression, such as you will have CPU usage. When you compress file, you have some overload on CPUs. Memory consumption during the compression and decompression. Disk input output, because you will read from a place and you will store in another place. So why, in fact, compression matters? Compression matters for several factors, starting by reducing storage cost. You have a database and you would like to store some files. We will speak about what file you can like compress them. And during that, you will reduce the cost by reducing the size. You store certain sizes, so you can use more databases. I mean, less databases to store more files than if you will store the file as it is with no compression at all. Such files may be like the logs. If you have a lot of logs in your application, some database backups, and the other certain file like text files. Also, it's enhancing the network speed. Enhancing the network speed because you reduce the file, so you reduce the payload of your API communication and transmission over HTTP. So that way you can have a large file, you compress this file on the front in the back end, and then you send it to the front end, and on the front end will decompress it, and this communication will be much better, in fact. Another thing is optimizing the file storage by storing and compressing text-based data. That's especially good for compression. We will get into type of compression. In generally, we have two different type of compression. We have reversible, that you can compress, decompress, and you still have the same quality, the same data. Irreversible, that where you can compress, but you will lose something during the compression. That's why it is irreversible. Let's get into reversible first. Reversible compression or lossless compression. Usually it preserves 100% of the original data. You will not lose any data when you use reversible. It's used mainly for text, databases, logs, and some images and audios. You know, we are working with XML, especially with JSON, so that's very good to use reversible type of compression. Another thing, it's rely on deflate-based algorithms. In fact, reversible use deflate-based algorithms and non-deflate-based algorithms. We will speak about deflate-based algorithms at the moment because in deflate we use mainly like algorithms such as LZ77, LempelZev77, and Hoffman coding. But how they are working? Usually, LempelZev77 is using a dictionary encoding. It replaces such repeated chunks or sequence with reference, but original data will store in a way that allow for reconstruction. Also, Hoffman coding, it's assign shorter binary code to frequent data pattern. You can say it like the hotspot in your virtual machine. But the mapping remains the same. You will have no problem. But since LZ77 and the Hoffman coding are lossless, no data is permanently removed. You still keep the original data among the compression and decompression. That will take us to the non-deflate based algorithm. Non-deflate based algorithms are also several and are used in different areas and based on each algorithm. Not every algorithm is good for everything. One is good for text, other is good for audio, etc. Like LZ4, ZSTED, LZMA, Brutally, BZIP2, and also back and ZBack. That's the reversible or lossless compression. That's move us to the second one, which is irreversible. That when you compress something, it's over. You can't get it back. And the irreversible is usually relies on different algorithms or the same, but we will speak about this. It's to achieve this higher compression ratio, you remove data. One of the most famous things that, let's say that you have audio file which stores, maybe you can say 196 bytes. If you reduce this byte to, let's say 128, so you already lost this part of the bytes. Maybe there are some tones will be removed which your ears will not be affected. That's how it works. But mainly the loosely or the irreversible compression are used for images, videos, and as well audios. Most of the media are already loosey compression, which mean you will not have any benefits if you compress already reversible. I mean, if you compress media further. So the significant question, why doesn't compression always work? Usually compression not always work for several reasons. That already compressed file. We spoke about this, which already loosely or loosey compression, irreversible. Like certain type file, as you can see here in the table, like BNG, most of them are media files already compressed, and each extension, in fact, it is, you can consider it like name of the algorithm used for that compression. So further compression will provide no benefits at all. But we can speak about now when you compress something, what could affect the compression is the compression level. Some algorithms will and libraries will provide you the possibility to tune the compression level from 0 to 9. If you make it 0, there is no compression. So there is even no need to use this compression mechanism. But 9, it will be the maximum compression. But remember that there is always a trade-off. You will have some CPU workload, some memory consumption, some input, output on your disk. Okay, now a very important also question. I got into this issue when I was compressing is, should I use base64 encoding? Base64 encoding, in fact, it is not that significant, but it is unless you are forced. Some libraries, for example, requires you to provide string. You have no option except string. So you would like to preserve the compression, so maybe you can encoding. But in fact, base 64 encoding is increases the file size by almost 33%. So you can check this condition yourself, it is worth or not. In some condition, I agree that you can use base 64. So let's check about the performance trade-offs when you work with compression and decompression. Okay, sorry. The trade-offs 100% will be related to resources you are used. The stronger compression requires more CPU and requires also more memory and also requires more time, input, output. So the question is up to you. That takes us to the final thoughts about compression. Remember the trade-offs when you choose your compression algorithm. Final thoughts are so simple. Should you use, in fact, compression or not? By applying the right compression, you can achieve, let's say, like 50% size reduction, but optimize the performance and also save cost. So compression in some condition is really good and is really important. And it's very good to use compression if you have text-based files and you can storage. I mean, that will be good for the storage or the network bandwidth limited. Your application is depends on like a specific amount in your database and you would like to use it and you don't have the option right now to increase the database, for example, let's say size. So compression is handy in that moment. Also network bandwidth will be good. I mean that transferring the files will save a lot of time and effort. But remember to choose the right algorithm based on your files that you would like to compress. But that's yes. So what when you shouldn't use compression is compressed file. We spoke about this before. Also base 64 file. I don't think it's a good option unless you are forced to use base 64 file. So stop talking. Honestly, I'm tired. I don't know. But anyway, it's time now for the benchmark. Let's have a quick benchmark to check the compression time for different file, let's say PDF and GPG, and one of the files will be also JSON file. That's a project link. You can find it on GitHub, but let's get into the project itself. I built the project, I tried to test the demo before the presentation to avoid the magnificent demo issues when you are working. As you can see, I believe control. Now, okay. So stay tuned. You have here two different packages, compression package, decompression package, and both of them are following the same exact pattern. I'm following factory pattern to make it easy for myself by just providing the compressions, this API compressor. I have it as interface. And from this interface, I'm providing several implementation of several compression algorithm. Here is the compression. I'm implementing the interface and I am applying my compression inside the interface. So that's first. I have several one. Then later on, inside the factory pattern, I am using to use the right compression by just calling it based on the data and the algorithm which I am provided to this factory method. And I have the service. Here is my service. In simple word, service will get the algorithms as an array, which I would like to test, and the byte data and the file name. I'm using this file name especially for like logging. And within the factory pattern, I'm getting the algorithm and I'm just calling the factory, compress, and that's it. Looping over all the algorithms I have. So if you would like to test your own algorithm, you can use exactly the same application, but you need just to add it here inside this algorithm. You can find it in utility. So compression is done. Decompression is following exactly the same pattern, is also factory and service and everything. They are both identical except one compress, one decompress. In a simple word, let's close all tabs. The reason why I will not go into the whole code to save time, that's first. Second, you can find the project on GitHub, and please feel free to do whatever you want with the code. Okay, let's check our main. Here we provide the file, the folder name. Where can I find my folders? And I'm providing different files, PDF, image, and JSON file. I'm calling the compression and decompression, and I'm having benchmark for PDF, image, and JSON. I'm using them here. So please feel free to use that. And all what you need to do, you will, under these files, original, you provide the files that you would like to use for the compression, and only you'll just change the name here. That's it. That will be enough to run your configuration. Now let's run our compression decompression. You can see it here. It's empty. Compression is empty. I will have files will be generated in under both of them, compressed and decompressed. Okay, so let's run. Benchmark. While it's running, I am providing benchmark first one for the PDF. Here is the compression and here is the decompression. You can see the size before you apply the compression with different algorithms, like all these algorithms. The size is the same, but the size after is a bit different based on the algorithm and how it's optimized to compress this kind of file, PDF. Reduction by 137, 220. So the best one from what I can see is LZ4 is good for PDF compression. But also remember that it comes to time. You can see that ZStat is somehow close to the same reduction, but in time is more faster. But it's used more memory. Also the same. So that's the trade-offs we spoke about. You have time, the CPU, and you have the memory used, and you have the reduction which you will have. So that's for PDF and with a different algorithm. When it comes to decompression, you can almost have similar, but decompression will always be faster because the algorithm already knows what to decompress. So there is no need for this kind of mapping. Let's say that you will take this chunk and you compress it, you take this chunk, you replace it. You don't do that when you decompress. So usually decompression is much faster because there is no overload of identifying which area you can compress during the decompression. Here it's just decompress file. So you have also the same how it's fast and how memory it's used. Almost they are all close. But I don't think that you achieved significance, because if you have like 2000 kilobytes and you only reduce it by 220, so it's totally depend on how many files also you can save. So there are always comparison in this area. When it comes to GPG is already compressed. You can see the reduction is almost nonsense at all. Even there is no reason to compress it because there is nothing to compress. You can say you only waste time and you waste resources. For decompression will be also the same. The reason why that it takes time, because really I have this size is a magnificent. It's like 180 megabyte. I'm compressing 180 megabyte JSON file, and that's why I especially kept it. It will take maybe few minutes for some algorithm to finish the compression and decompression. Yeah, you can see it looks like 14,000 milliseconds. It's something like few minutes. You need to find this, like subtract, divide, and do your best. So same as you can find it here, like LZMA is not optimal for this kind, but I can see that the best one for the moment, even for the time, is LZ4 is very good with JSON files, and somehow time is not bad. But here you can see GZIP, it already takes longer time, means more CPU resources, but less memory footprint. Also the same will be with decompression. Guys, in fact, that's it for the demo and the benchmark. And I will quickly show you my last things. Yeah, here you can find the project link on GitHub. Please feel free to check it. Also, I am leaving some links. There are one article, you'll find it in our community. The community name is Curiosity Corner. This article is already how can you use the compression and decompression. This links for my YouTube channels. And bottom line, I would like to thank every one of you for your time, and hopefully that presentation added even little bit value to your knowledge, and I will be more than happy to get your feedback. So in quickly, that's the article how it looks like in our community, where you can find all the decompression which I just mentioned, but in a written article. So please feel free to find it. And that's my GitHub, Java MSDT, Java, and under POC compression, you'll find your compression presentation. So I believe that's it for me. I know maybe I was boring. So now it's time to transfer you to more interesting presentation with my friend Egli. So please, Egli, you can kick in and share the people with a better presentation than mine. Thank you so much for your time.